Very good morning, students. Welcome to the another first video of online classes. Okay, in the previous video I have sent you a class 7th video which deals with the physical quantities and measurement, and that video is only for your recap. Okay, so today we'll start our second chapter which deals with the physical quantities and measurements. Okay, so let us begin with one. Before going to the chapter, so I have to tell you that according to our new syllabus, some portion of our book is omitted, and the content which I given here, that much only you have to be read. Okay, the other contents in the book no need to read. Okay, so let us start with the first one, density. Then second one is unit of density, then determination of density of regular solid, vessels for measuring of volume, determination of density of liquid. Then we will have density bottle, determination of density of a liquid using the density bottle, then relative density, then unit of relative density, then we have density of a substance in its different states, that is solid, liquid and gases. Then we have floating and sinking. Okay, these contents only you have to read in chapter 2 according to the reduced syllabus of 2021. Okay, so whatever may be given extra in the book, you have to you have to leave those uh, topics. Okay, let us begin with the first one, which is density. So density is what? It can be defined as how much a space, an object or substance takes of, or you can say that its volume in relation to amount of matter in the object or substance. Okay, so in the previous video also we have discussed about this density only in class 7th video. Okay, so I hope you all are understood what is density and what is the formula for that. And the formula for that is what? The mass of the substance divided by the volume of the substance. So we can say that the density can be defined as quantitatively like this: the ratio of mass of the substance to the volume of the substance. Okay, so equal mass of the substance have equal volume. For example, you can say a volume of cotton is much larger than the equal mass of lead. In other words, density leads is more than density of cotton. Okay, so in this example we can learn that equal masses of different substances have different volume. Okay, although the mass of lead and cotton are equal, but the volume of cotton is very more. Okay, so the next one is what? Equal volume of different substance have different masses. Okay, that means what? Another example we can take: the example, the mass of iron is more than the mass of equal volume of wood. If you take the equal volume of same shape and size of two materials, one is iron, another is wood, then you know that the mass of iron is more than that of wood. So in this example we can learn that equal volume of different substance have different masses. Okay, now the units, so we'll elaborately read about the units. Let us leave this one. Then we'll go for the unit of density. Okay, we know that the unit of density can be calculated by taking the ratio of unit of mass divided by unit of volume. Okay, so unit of mass is what? Unit of mass is gram, or you can say kilogram, and unit of volume is what? Meter cube, or you can say centimeter cube. So in SI system we are taking kilogram per meter cube. In CGS system it is gram per centimeter cube. Okay, then we have the relationship between SI and CGS units of density. Okay, now we have to find the relation between kg per meter cube and gram per centimeter cube. Okay, this is also uh, uh, elaborately discussed in the previous video. Okay, and here we can write 1 kg per meter cube is equal to 1 kg by 1 meter cube, and 1 kg is equal to 1000 gram, 1 meter cube is equal to 100 centimeter cube, because 1 meter you can replace with the 100 centimeter. So now it will be, now the result will be what, 1 by 1000 gram per centimeter cube. So we can write like this: 1 kg per meter cube is equal to 10 to the power minus 3, because 1 by 1000 is given, it can be written as 10 to the power minus 3 gram per centimeter cube. Otherwise we can write 1 gram per centimeter cube is equal to 1000, take to this side, it will be multiply by 1, so it will be 1000 kg per meter cube. So 1 gram centimeter cube is equal to 1000 kg per meter cube. Okay, then we have a determination of density of a regular solid. Okay, the first we have to measure the mass of the given regular solid by using beam balance. Then you have to find the volume of the regular solid by some given formulas. If it is a cube, then you can put the formula one side to the power cube. If it is a cuboid, then you have to put the formula length into breadth into height. If it is a sphere, then you can put the formula 4 by 3 pi r cube. Okay, and if it is a cylinder, then you can put the formula pi radius square multiplied by height, and here the value of pi is 3.14. Okay, so you can put, by putting these all formulas, add is a regular solid, this all formulas, by putting these all formulas we can find the volume. So now you have mass, now you have volume also. Now put the formula density is equal to mass per volume, we'll get the solution, we'll get the density of the regular solid. Okay, so the density of irregular solid is not in your syllabus in this year. Okay, then we have, for example, one example we will take. If mass of cube is iron is given as a 210 grams and one side of cube is centimeter cube, so volume of the cube should be, it is the cube side cube will be its volume. So volume will be 3 to the power 3, it will be 27 centimeter cube. Then density of iron is, we can put the formula D is equal to m by V, mass per volume. Mass is 210 gram and volume is 27 centimeter cube. So we can by solving these two, we can have 7.78 gram per centimeter cube. Okay, then we have the vessels for measuring volumes. Okay, the first one is measuring cylinder. Okay, it is made up of glass, plastic, and measuring in milliliters. Okay, the capacity of measuring cylinder is marked on it. See here written is 100 ml, 100 ml, and with at the bottom there is a 0 mark is there. So the different type of measurable measuring cylinders are there, like that 100 ml, 200 ml, 500 ml, like this. Okay, then the next one is what, measuring beaker. Okay, measuring beaker is made up of glass, plastic, or metal like aluminum also, and the capacity of measuring beaker is marked on it, and it do not have any 0 mark at the bottom, because if you completely fill the bottles, completely fill the beakers, it will give you the written measuring the written amount of liquid inside the beaker. Okay, so it is used to take a fixed volume of liquid, like we can measure oil, milk in by using measuring beakers. Then the third one is eureka can. Okay, so it is a glass or metal also, beaker like structure with a side opening near its mouth. Okay, here see there is a side opening is, and this is called as spout. Okay, then thus the beaker can contain a volume of liquid up to the spout, then it will have a volume up to this only. Okay, up to this only we will have a volume. If the liquid is increasing above the spout, then it will be the liquid will be overflow through the spout. So there is a fixed volume in the Eureka can. By this also we can have the measurement of volume by using a Eureka can. Then we have a determination of density of a liquid. Okay, to determine the density of a liquid like oil and milk etc., we have to determine the mass of the common by using common beam balance, and volume by using the measuring cylinder. Okay, if you want to suppose if you want to determine the density of the milk, then what you will do, the first step is what, take a beaker, measure the mass of the empty beaker using the common beam, and let the mass is m1 grams. At the second point, what you will do, then the milk you have to pour in the vessel, then the volume we have to be measured. Suppose the volume is 50 ml, or you can write in centimeter cube like 50 centimeter cube. And the third point, then you have to transfer the milk into the empty beaker, then measure the mass again, then the mass of the beaker you can find, and it can be m2. Okay, now the difference m2 minus m1, which gives you the mass m of the milk. So mass of the milk is m2 minus m1, and volume is also, we know 550 centimeter cube. So by to calculate the density of the milk, what you will do, density is equal to mass per volume. So mass is given as 51.5 gram. We have found here by taking the difference m2 minus m1, and volume is, we found what, volume we found 50 centimeter cube. Okay, by dividing these two we will get 1.03 gram per centimeter cube. Okay, then what is density bottle? See, let us see the figure 2.6 density bottle. Okay, it is a simple glass bottle having a glass stopper at the neck and used to determine the density of the liquid. Okay, then the bottle can store a fixed volume of liquid. Generally it can be of 25 ml or 50 ml. Okay, and the stopper has a narrow hole here. See, this one is the hole. Okay, stopper has a narrow hole here. When the bottle is filled with the liquid, the excess liquid will overflow and drains out through the hole. Okay, so this is used to measure the density of the liquids. So how it can be used, let us have an eye on that. So determination of density of a liquid using density bottle. So what you will do, first determine the weight of the we have to write mass of the density bottle. Suppose that one is m1 when it is empty. Then what you will do, then fill the bottle with water and wipe outside and make it dry. Then once again measure the whole volume of the whole mass of the bottle. Then it will be mass of the bottle with water is let us say m2. Then what you will do, then fill it with the liquid you want to determine the density. Then once again you measure the mass of the bottle with liquid. Suppose that one is m3. Now we can say the mass of the water is equal to m2 minus m1. By m2 minus m1 we will get the mass of the water, and once again the mass of the given can be mass of the given liquid is given as m3 minus m1. But we know that the density of water is 1 gram per centimeter cube. So volume of water contained in the bottle gives the volume of the bottle. So volume of the bottle is what, mass of the liquid of mass of the water is equal to the volume of the liquid, or volume of the bottle. So the volume of the liquid is m2 minus m1, and we know the mass of the liquid is m3 minus m1, and the volume is m2 minus m1. Now you can put the formula, density of the liquid is equal to mass of the liquid divided by volume of the liquid, and mass of the liquid is m3 minus m1 and volume is m2 minus m1. By putting this formula we can find the liquid of the density of any liquid by using the density bottle. So here the mass can be calculated by using the density bottle. Also the volume can also be calculated by using the density bottle only. Then one example we will see here. We suppose the mass of empty bottle is given as m1 is equal to 30 gram. Then we have to pour the water and we have to measure it once again. Then the measuring water is filled with the mass of bottle filled with water is measured as m2 is equal to 60 grams. Then what you will do, then fill the bottle, empty the bottle filled with the given liquid. Suppose that one is 54 grams, which is given by m3. Okay, now you know that the mass of the liquid is m2 minus m1, it will be 60, mass of the liquid is m3 minus m1, it will be 54 minus 30, it will be 24 grams, and the volume of the liquid is m2 minus m1, that is 60 minus 30, it will give you 30 centimeter cube. Okay, now you have to put the formula mass per volume 24 gram divided by 30 centimeter cube, it will give you a result of 0.8 gram per centimeter cube. So by to find the mass of the liquid, you have to take the difference of m2 m3 minus m1. To find the volume of the liquid, we have to take a difference of m2 minus m1. Okay, so density of liquid we have found by using the density bottle in this procedure. Okay, so today, thank you for today, and in the next class we will have the rest of the topics of chapter 2. If you have any doubts regarding this, uh, how much we have completed today, then let me know. Ask me in the personal WhatsApp. So thank you once again. Have a nice day.